In this concept check question, you're asked to use the appropriate curved arrows to map the flow of electrons in the acid-base reaction shown. Remember that the arrow originates at the base, and more specifically at the lone pair of the base, and then it ends at the proton of the acid. So here the thiolate is the base, so the arrow begins at the sulfur lone pair and ends at the benzoic acid hydrogen. Then the electrons in the OH bond move to the electronegative oxygen. We can draw that arrow starting between the oxygen and the hydrogen, but we have to be really careful to not be sloppy. If it starts at one of the atoms, then it's incorrect. So if we want to make sure that there's no confusion, we can always redraw the acid with the OH bond drawn out. That makes it much easier to be sure that the second arrow begins at the bond and not at any of the atoms. This question asks you to determine to which side the equilibrium lies. Remember that when we're determining the side of the equilibrium, we need to compare the strengths of the acid and the conjugate acid. So I'll start by assigning the acid and base and drawing in my reaction arrows to make sure we're all in agreement on which two species we should be comparing here. The anionic nitrogen is the base. It will abstract the hydrogen from the alcohol to give the alkoxide anion and the neutral amine. The neutral amine is the conjugate acid. So to determine the equilibrium, I need to compare the alcohol pKa with the amine pKa. And I can get these pKa values from tables. Okay, they're shown here. And these pKa values indicate that the alcohol is the stronger acid. It has the lower pKa value. Then I just need to remember that the equilibrium will lie toward the weaker acid. So here it will lie toward the right. This means my equilibrium arrow should feature a longer arrow pointing to the right and a shorter arrow pointing to the left. One final question for this chapter, which is asking you to determine now not the strongest acid, but instead the strongest base. So let's think about what that means. A stronger base will be more prone to accept a proton. That means that the negative charge will be less stabilized. We already learned that the negative charge is more stabilized on a larger atom. So here it will be more stabilized on sulfur. If that negative charge is more stabilized on sulfur, then the oxygen anion, which is less stabilized, will be more prone to accept a proton. That means that the oxygen anion is more basic than the sulfur anion.